The James Webb Space Telescope, JWST, has once again surprised the world of astronomy by revealing discoveries so improbable, they defy long-held assumptions about planet formation. In a groundbreaking observation, the telescope detected a new class of objects in a galactic nebula, dubbed Jupiter Mass Binary Objects, or JUMBOs. These peculiar celestial bodies are so unusual that their existence challenges everything scientists previously believed about how planets are formed. Jupiter Mass Binary Objects, or JUMBOs, are massive planetary pairs, comparable in size to Jupiter, orbiting each other in interstellar space. What makes these objects extraordinary is that, according to established models of planet formation, they should not exist. Yet, there they are, discovered in the Orion Nebula, a star-forming region of the Milky Way known for its brilliant clouds of gas and dust. The existence of these JUMBOs has astonished researchers and is forcing them to reconsider fundamental principles of planetary dynamics and formation. Historically, it was believed that planets form from the dust disks that orbit young stars. Over time, this material clumps together due to gravitational forces, eventually forming planets that settle into stable orbits around their parent stars. However, the JUMBOs appear to have broken free from this process entirely. Instead of orbiting a star, they revolve around each other, isolated in the vast reaches of interstellar space. This finding upends the conventional understanding of how planets should behave, leading to one of the most significant astronomical revelations in recent years. The Orion Nebula, where the JUMBOs were discovered, is a luminous star-forming region located about 1,344 light-years away from Earth. It is one of the brightest nebulae in the sky and is visible to the naked eye in the Orion constellation. For astronomers, this nebula provides an unparalleled opportunity to study the early stages of star formation and the birth of planetary systems. Within the nebula, molecular clouds collapse under their own gravity, giving rise to new stars, around which planets often form. It is within this dynamic environment that the James Webb Space Telescope detected the JUMBOs, turning the nebula into the center of one of the most extraordinary discoveries in recent memory. In addition to JUMBOs, the nebula has long been a subject of study for those seeking to understand the processes that shaped not only our solar system but the universe at large. However, the discovery of these strange, detached planetary pairs raises new questions about the mechanisms that govern planetary formation and dynamics. The discovery of 40 Jupiter Mass Binary Objects in the Orion Nebula is not just extraordinary, it is statistically improbable. These JUMBOs represent almost 10% of the free-floating planets observed in the nebula by the JWST, a rate that should be impossible according to current models. This statistical anomaly is so extreme that scientists are now scrambling to develop new theories to explain their formation. In the conventional view, planetary systems are tightly bound to their stars. Planets form from the material in a star's circumstellar disk and remain locked in stable orbits around the star due to gravitational forces. The existence of these free-floating JUMBOs, completely detached from their parent stars and orbiting each other instead, seems almost like a cosmic impossibility. And yet, they exist, throwing planetary dynamics into disarray. Adding to the mystery is the fact that these JUMBOs don't just exist in isolation. There are 40 pairs of them in a relatively small region of the Orion Nebula. Imagine a large dance hall where 40 pairs of dancers have somehow congregated in one corner, performing a routine so different from everyone else in the room. The sight would be so bizarre that you would probably need to look twice to believe what you were seeing. This is precisely how researchers felt when they first observed the JUMBOs. The discovery of the JUMBOs forces scientists to reevaluate many of the principles that have long governed their understanding of the cosmos. For decades, the process of planetary formation was understood to be largely predictable. Planets form in the circumstellar disks around stars, accumulate mass through accretion, and remain bound to their stars due to gravity. However, the existence of JUMBOs shows that there are gaps in this understanding. How could two Jupiter-sized planets form a common gravitational center without being captured by a star? One hypothesis is that the jumbos may have formed through the dynamics of multi-body systems, in which gravitational disturbances could cause planets to be ejected from their home systems. These disturbances might occur during close encounters with other stars or through collisions between stars. Another idea is that massive collisions between stars may have torn planets from their original orbits, leaving them to wander the cosmos as binary pairs. Whatever the case, the existence of jumbos suggests that planetary formation is far more complex than previously thought. The high frequency of jumbos in the Orion Nebula may indicate that they are not just an anomaly but part of a larger cosmic pattern that scientists have not yet fully understood. It is possible that jumbos are more common than previously thought, and we simply lack the technology to detect them until the advent of the James Webb Space Telescope. Perhaps the most intriguing aspect of the discovery of jumbos is the new possibilities it opens for the search for extraterrestrial life. While the jumbos themselves are unlikely to be life-friendly, their existence points to a greater diversity of planetary systems than scientists had ever imagined. If such unusual planetary pairs can exist, what else might be out there? The discovery of jumbos invites us to imagine new possibilities for habitable planets. For instance, what if, instead of finding a pair of Jupiter-sized gas giants, we discovered a grouping of Earth-like planets? Could such planets support life? Could they even be connected in some way? Such a discovery would force us to rethink humanity's place in the universe. It would suggest that life-friendly worlds could be more common than previously thought, hidden in the far corners of the cosmos, just waiting to be discovered. Moreover, the discovery of Hycean planets, super-Earths that are larger than Earth but smaller than Neptune, with a composition mostly made of water, could offer even more fertile grounds for the search for life. These planets, also detected by the JWST, are now believed to be among the most common in the universe, and they may offer conditions more suitable for life than Earth itself. As the James Webb Space Telescope continues its mission, scientists are eager to learn more about the jumbos and other unusual planetary systems that may be lurking in the depths of space. Researchers are now working on simulations and theoretical models to understand how jumbos might have formed and what factors led to their current state. The JWST, along with other ground and space-based telescopes, will be used to gather more data from the Orion Nebula and other star-forming regions, as scientists seek to unravel the mystery of these strange planetary pairs. Further observations will help clarify whether jumbos are unique to the Orion Nebula or whether they exist in other star-forming regions as well. If more jumbos are discovered elsewhere, it could point to a new, previously unknown mechanism of planetary formation. It may also provide clues about the early evolution of our own solar system, where similar processes may have occurred. In addition, the discovery of the jumbos has sparked renewed interest in understanding the dynamics of planetary systems closer to home. In recent years, evidence has emerged that the order of the planets and moons in our own solar system may not be as clear-cut as once thought. For example, Pluto and its moon Charon could be reclassified as a double planetary system. There is also evidence that Neptune may have once been an interstellar object that migrated into our solar system. Even Mercury, the smallest planet in the solar system, presents its own set of mysteries. The work on jumbos is still in its early stages, and scientists are only beginning to scratch the surface of what these objects can teach us. However, one thing is clear: the discovery of jumbos has already revolutionized our understanding of planetary systems, and it is likely to lead to even more groundbreaking discoveries in the years to come. In many ways, the discovery of jumbos is a reminder of how little we still know about the universe. For centuries, astronomers have relied on established models and theories to explain the cosmos. But time and again, observations from advanced instruments like the James Webb Space Telescope challenge those models, showing us that the universe is far more complex and mysterious than we ever imagined. Just as the man James E. Webb drove the Apollo program forward, the telescope that bears his name is pushing the boundaries of human knowledge. From the discovery of jumbos to the detection of distant exoplanets, the JWST is shedding light on the darkest corners of the cosmos, answering questions that we couldn't even ask with previous technologies. As we look to the future, we can only imagine what else the James Webb Space Telescope will reveal. With each new discovery, we are reminded that our understanding of the universe is still in its infancy, and we are likely only at the beginning of an exciting journey into the unknown.